Hey there, welcome back. So in the previous video, we have seen multiple different operations that you can perform on top of tensors, and this video is just going to be a continuation of that. So here we'll just see a couple of more operations that you can perform and also the different matrix operations that you can perform on tensors, right? So let's get started. So here we are in the same Jupyter notebook. We have all the code written in order to save time, and let us execute them one by one, and I'll just explain on the way, right? So here the first command that we have, we are just trying to print the random tensor that we have already created. So this is it. So now starting with the first function, and that is for sorting the tensors, right? So what do we really mean by sorting? So say you have a use case in which you have a tensor quite like this, and what you have to do is you have to sort the tensors by rows or by columns, right? So you have all these rows over here, right? So say in the first row you want all these three values to be the shortest values, or I should say the smallest values in these columns, right? Or you have three columns available, right? And in each of these columns you want you want them sorted, like the first value should be the smallest one, the second value should be the the medium one, and the third value should be the largest one. So if you want it like that, then there is a function in Torch which you can use, and that is called the sort function. Now here you can see that the syntax of the sort function is written. So here you basically call torch.sort, and in this function you pass the tensor that you are willing to sort, and you finally pass the dimension parameter or dim, which is, like, for this case it's 0. Now if it's passed as 0, what will happen? Then it will only check row wise, right? So you have, say, like all these rows. So for each row it will, like for all the rows, it will just check the columns. So for example, this is the first column for all the rows, right? So once I run this function, then this column is going to be sorted since I'm checking row wise. And again, this sort function returns two things. One is your sorted array, right, or sorted tensor, and the other thing is the indices tensor. Now the indices tensor basically is going to contain, so what, how the values changed, so that information will be there in the indices tensor. So let us first run it, and then we can better understand. So here you can see that this is now our sorted tensor, and this is the indices tensor. So let us first look at the sorted tensor. So this is the original tensor. So here you can see that the first value is 0.56, the second is 0.86, and the third is 0.51. Now among them, 51 is the lowest one, this is the second second highest, and this is the highest one. So you can see pretty much that's how it has been sorted. 0.51 became the first, 0.56 became the second, and this became the third, and that's the same story for all the other two columns. So here 0.97 was the highest, and it went here, right? 0.40 was the lowest, so it came at the top. So this is pretty much what happened, and this indices tensor will basically tell you the same thing. So here, at the first position we have the index 2 written, which means that the element which was at index 2 now is at index 0. So here the element at index 2 is 0.51, so it came to index 0. Similarly, here the index is written as 1, that means the value in index 1 is now in index 2. So this is what the indices tensor represents. So similar to dim0, you can also do it using dimension 1, and if you execute this, you will see that this time the sorting has looked column wise. So basically in this first column, if you see, the lowest value is again 0.56, the highest value is 0.97, and the medium value is 0.93, and this is how they have sorted. So 0.56 is here, 0.93 is now the second value, and this is the third value, and the indices tensor pretty much describes the same thing again. So this is all about the sorting function that PyTorch has. Now coming to this function. So now say you have a tensor, right? And in that tensor you have positive values and you have negative values as well. And now what you have to do is you have to find the absolute values, like you have to find a tensor in which all the values are having the absolute values. So how you can do that? You can just call the torch.abs function, and you can pass in the tensor which has the negative values. So now let us first create a tensor that has negative values, and then we'll call this torch.abs function, and we'll pass that negative tensor. So here you can see that the negative tensor has all the negative values, and the absolute positive tensor has all the positive values. Now coming to the third kind of functions. So now say you want to find out the maximum or the minimum in a specific dimension. For example, you have the torch like tensor positive, right? And say in this you are willing to find out the maximum in each of these columns, right? So here this is one column, right? This is the second column, and this is the third column, and you are willing to find out what is the maximum values in each of these columns and how you can do such a thing, right? So for that we have a function here called torch.argmax, and here you pass the tensor that you are trying to look, and you also pass the dimension. Now the dimension 0 means again that it will look for it will look row wise, right? And if it looks row wise, you'll get the result as columns. So we will just execute it, and here you can see that the tensor it has returned is 1 1 1, and the reason it has returned like that is because like all these values are the highest values, right? So in this column 3 is the highest value, in this column 4 is the highest value, and similarly for the last column 5 is the highest value. Now if you run the same thing with the dimension as 1, you will see it's like 2 2, right? Because in the now when dimension is 1, it will look column wise, and when it looks column wise, so you basically get 2 values since you have 2 rows. So for this first row the highest value is 3, which is at index 2, so again we have 2 over here, and 5 is the highest for the second row, so we again have 2 over here. Now like argmax, you also have argmin, and it pretty much does the same thing. So it will just return you the lowest indexes and so on. Okay, so now coming to the different matrix operations that we have in PyTorch. So first let us see that what tensors we already have defined. So we have a tensor 1 which contains some random values, and we have tensor 2 which contains only ones. So now let us go through all these different operations that are possible. So the first thing is element wise addition. So this is something that you have already seen. So basically you have a tensor, and say you want to add some value to all the values in the tensor. How you can do that? Okay, so for that the simplest way by which you can do is you just do a plus. So it's like tensor 1 plus 0.5, and if you run it, you will see that you are getting another tensor, right? Then that tensor contains all the values where the this number 0.5 is added. Now similar to adding a specific number, you can also add 2 tensors element wise. So you have here tensor 1, you have tensor 2, and if you add them you will get a tensor where everything is added element wise. So here say 2.4 was there, and here you have 1, so the result is 3.4. Similarly 2.6 and 1 is 3.6. Now there are also other ways. Torch also provides some functions using which you can pretty much do the same thing. So here say you have the torch.add function, and in the first parameter you have passed tensor 1, the second parameter you have passed tensor 2, and you are storing the result in tensor added. So if I execute this, you will see that you are getting the same output over here, since torch.add pretty much does the same thing, right? Which is element wise addition. Now similar to addition, you can also do element wise division. So if I execute, you can see that this is pretty much the result of element wise division. You can even do element wise multiplication, which will return you the same thing. Now again, for all these division and multiplication and all these things, you can even use these operators which you have in Python, and if I execute it, you will get the same result again, right? So like these are the different element wise operations that you can perform. So now let us look at another element wise operation which is pretty common in case of neural networks. So here, if you remember, we had defined an 1D tensor previously, right? And it contained 1 2 3. So now let us try to calculate the dot product of this tensor with itself. right? So what happens if we try to calculate the dot product of two tensor 1Ds which we have? So for the dot product, you have a function in torch called torch dot dot, and in this function you just need to pass the two tensors for which you are willing to calculate the dot product. Now just remember one thing in case of dot product, that both these tensor have to be of the same shape, like the exactly same shape has to be there in order for you to calculate the dot product. Now here we are using the same tensor twice, so it doesn't matter, so we can easily use it. So if I just run it, you see that it's 14. So if you know the formula of dot product, right? So 1 into 1 plus 2 into 2 plus 3 into 3, and that gives you 14. Now let us look at some matrix and vector multiplications again. So these are pretty much the last couple of functions that we'll see. So let us create a tensor first. So we have here tensor matrix, and again it is just a tensor which contains two rows. So if I execute, you can see it's a 2D tensor. Now let us create a vector. So by vector, it's just an 1D tensor, right? So we have a 1D tensor, we have a 2D tensor. Now let us see how the matrix vector multiplication works in torch. So you have a function called torch.mv. mv stands for matrix vector, and here all you do is you pass the matrix, you pass the vector, and if I run it, you see that I get 12 and 30. So how does matrix vector multiplication work? Now this is like plain maths. So you basically multiply each row of the matrix with the vector, then you add up all the all the multiplicated terms and all these things, and that is 12 in this case. Similarly, you multiply the vector with the second row, and then you add up all the terms, and that makes 30, right? So like this you have the resultant 1D tensor. Now similar to matrix vector multiplication, you can even do matrix multiplication, right? So here I'll just create another matrix. So like the first matrix that we have, so it's a 2 by 3 matrix, and the second matrix that we have, it's a 3 by 2 matrix. So you would remember, right, from the good old days when we learned matrix multiplication. So in order for us to multiply two matrices, the number of columns of the first matrix must be equal to the number of rows of the second matrix, and this is pretty much what will happen in this case as well. So here we have the first matrix for which the number of columns is 3, and for the second matrix the number of rows is 3, right? So we'll be able to multiply. So here we have passed the matrices, right, and we'll just execute it, and you can see it's this. Now just one thing over here, here I've just passed matrix 2 as the first matrix and matrix 1 as the second matrix, and because of that you are getting the resultant you are getting the result as this. But if I had switched it, for example, it's like this, and matrix 2 over here, then you'll get some different result, which is a 2 by 2 matrix. So this is pretty much it, with all the matrix functions and all the different operations that you could have performed on PyTorch. I know that there are many more different operations that you can perform, but for now this is, I believe, is sufficient for all the work that we are going to do in this course. So yeah, that's it. So in the next video, what we will do is we'll look at the interoperability between PyTorch and NumPy, since we have been talking a lot about the deep integration or the tight integration that PyTorch has with Python. So it's really important for us to see that why is that so, how PyTorch and NumPy can be used side by side and so on. So that's it, and I'll see you in the next one.